Okay, so good afternoon. Today is November 5th, and we're going to start a new chapter today, chapter 11. We did not have class, a live session on November 3rd on Tuesday, but I asked you to watch a video regarding the lecture before today's class. So if you don't understand a few things in the beginning of this new chapter, I suggest you go back and watch that video. I sent an email out about this, so if you did not receive my email, let me know. And I also said that your test scores are available on MyLab. So scores that you see, they were not exactly curved, but I was very lenient with the grading. I gave you partial credit if you had shown your work, because I don't want to discourage you. I want to make sure that you really understand the material and you're prepared for the final exam. So the final exam is going to be very similar to the test that you just took. Same sort of questions. I'm not sure if I'm going to increase it by the number of questions because I want to wait and see once we're closer to the final exam, the accumulation of scores, and then make that decision. A question for me here. Would you be able to share the average score for exam 2? Sure, I can let you know. I think I can let you know today by the end of the class. So just remind me and I can put that in the chat box. Okay, so today we're going to start with chapter 11. And you should have seen that video with the first few slides of chapter 11. I'm going to start with, so let's actually go back first. So chapter 11 is about confidence intervals for means. And I'm going to start by explaining that this entire chapter is about estimation. So there are two types of estimators, a point estimator and an interval estimator. Point estimator is a single value. This you already know. You've seen this and you've done this before. You've calculated a point estimator, the single value. It could be the sample mean. So that's one individual value. So using that one value, you're trying to estimate something about the entire population, the population mean. So that's considered your point estimator. But it's not exactly accurate. I mean, how can you take one single value that's based on your sample and say that the entire population is going to have that value? It might not be that value. It might be less. It might be more. So it's not a perfect way of doing prediction or an estimation. A different type of estimator is an interval estimator. So now you're looking at a range of numbers, not just one single value. So you have a lower limit and an upper limit. So it's a range of numbers. And now you can make this prediction and you can estimate that the population will have a value that will fall somewhere in this range. The method that I'm going to show you today, you can use this sort of analysis called confidence interval estimation, and you can even state how confident you are of your answer. So you can say you're 90% confident, 95% confident. So that's why we use the interval estimator. It's a more accurate way of making an estimation or a prediction. This is what was shown in the last lecture for November 3rd when you watch the video. So I want to help you visualize this idea of a confidence interval. So let's look at this graph. You're looking at a normal distribution, right? So it's a bell-shaped curve. It has all the properties of a normal distribution. The axis on the bottom is your x-axis. The center is that single value, the point estimator. So that center, and I'm going to write on the slide here, is your x bar, your sample mean. And then if that's your single value, we're saying that it's not just enough to come up with a single value and make an estimation about the entire population. A better method would have an interval. So this is one point here, the lower limit, and this is the other point here with an upper limit. So this entire length is your confidence interval, your interval estimation. So the lower limit is also called lower confidence limit, and this upper limit is also called upper confidence limit. And then you're going to say that you have some level of certainty, some confidence, and that confidence is this 1 minus alpha. 1 minus alpha is your level of confidence. Now, this was also explained in the video lecture. So what is this alpha? Alpha is your level of significance. So alpha is also called error. It's the risk level that can be tolerated. So usually this is known if you're doing an experiment or it's a project. Your company tells you that you have to be within 1% error or 5% error or 10% error. So that's the risk level that can be tolerated. And based on alpha, that's how you get your level of confidence, which is 1 minus alpha. So alpha is in this unshaded region here. So if I take both sides together, that's alpha. But individually, because it's 2 and they're equal in area, the right side is alpha divided by 2 and the left side is also alpha divided by 2. So this is your confidence interval from the lower limit to the upper limit. So in this class, what I'm going to do is show you how to construct your confidence interval. So this is how the chapter is going to be sorted out. First, you learn how to construct confidence intervals for mean in order to estimate the population mean. Then you will learn how to construct confidence intervals in order to estimate population proportion. When we deal with mean, we have to either know our population standard deviation, sigma, or sometimes we don't know what that value is. We don't know population standard deviation. So that's a different method when sigma is unknown. So when I say known, I'm saying that either it's given to you in the question or this same experiment has been done in the past, or there's historical data that has already been collected. So for example, if we're talking about trying to find out the average selection of the average number of people who thought that a certain referendum should be included, then this is something that they could compare to past voting. And then you know what the population standard deviation is because there's something that has happened before and you can compare it. But if it's something brand new that has never been done before, then you are going to use the method where sigma is unknown. So in today's class, we're going to focus on constructing a confidence interval to estimate the population mean when your population standard deviation is known. Okay, so any questions for me before we start? Just make sure you understand the reason why we're using confidence intervals, because we are not satisfied with using a single value, a point estimate, in order to well, not hypothesize, but in order to make an inference about the population. Any questions for me?
Wait, can you repeat that again? I missed the significance.
Say it again. What's your question?
I'm sorry, I just think can you repeat the last sentence that not the last one, the last couple of sentences that you said for this slide?
Yeah, so confidence interval estimation is going to be used because we're not satisfied with using point estimate to make an inference about the population. It's not enough to use a single value to estimate something about the population. So for that reason, we're going to use an interval, a range of numbers, rather than a single value. So by using a range of numbers, which is called a confidence interval, now we can accurately estimate something about the population. So in this case, we're going to estimate the population mean. And more specifically, we're estimating it when the population standard deviation, sigma, is known, is given to us. Okay, so moving on to the next slide. Now, before I give you the formula and we start crunching numbers, let's really understand the assumptions. So first thing is I have to fix this because this shifted here. The confidence interval for population mean, mu, when sigma is known. So the first assumption is that the population standard deviation is known. Okay, again, when you're doing your homework or you have this on test, what does it mean by is known? That just means that it's given to you in the question. Okay, so in your homework, it says standard deviation is equal to a certain value. So that's the first assumption. Second assumption is that your population is normally distributed. Now, usually this is given in the question. You're told that you're dealing with a normal distribution, because if it's not a normal distribution, okay, so that's the third assumption. If your population is not normal, use a large enough sample. So what does that mean, a large enough sample? What should n be if I'm not dealing with a normal distribution? Yes, Rad, you're right. So n must be greater than 30. So as long as my sample size is greater than 30, then I'm sure that then I can assume that I'm dealing with a normal distribution. If it's less than 30, I cannot make this assumption unless I am already told that it's definitely a normal distribution. So these are the assumptions. Next thing I'm going to do is explain the formula. Because once you understand the formula, everything else is pretty simple. So looking at the formula here, it says x bar plus or minus z subscript alpha divided by 2. And then if I was in the classroom, I would write this with the parentheses, times sigma divided by square root of n. So now a few things happening here. Let me start with x bar. So x bar, we're told, is the sample mean. So let me fix this here. This should say x bar. So that's your sample mean. So you take a few items into your sample or a few people into your sample, and then you take the average, and that's your x bar. And n is your sample size. So you know all this stuff, nothing new. N is your sample size. Sigma is your population standard deviation. Now this should be given to you in the question. So it's not something that you would have to calculate because this is known, given to you in the question. The only thing left is your critical value. So z subscript alpha divided by 2 is your critical value. So that's really the only complicated thing to find. And even that's not really that complicated because you know how to find the z-value from the table or using Excel. So the formula is saying x bar plus or minus critical value times all this. So how do you find the critical value? Well, it's based on alpha, and alpha is your level of significance. So that means you need to know what risk level is that can be tolerated, or you need to be given the level of confidence. So if you're working on your project, your company will tell you, well, you have to be 90% confident of your answer or 95% confident of your answer. So a few more things in this formula that I want to point out before I show you how to get this critical value. So this formula, this part of the formula right here, I'm going to type it in. So sigma over square root of n, just that part is your standard error of mean. Now, this is what you saw in the previous chapter, chapter 10, when we discussed sampling distribution of mean. This is where that formula is coming from, sigma over square root of n. That's your standard error of mean. I gave you 3 different terms for the same thing, so this is that. Sampling distribution, standard error of mean. And then you need to know this entire right side of the formula. So the plus or minus z times sigma over square root of n. This is your margin of error. That's your margin of error. The reason I'm showing you this specifically is because in your homework, when you're working on a problem, as you know, there are many different parts. So you'll have part A, B, C, and so on. You might be asked to find the standard error of mean. So you need to be able to identify that it's just this right part of the formula. You'll be asked to find the margin of error, which is plus or minus z times all of this. So make sure you mark this in your notes, margin of error and standard error of mean. So moving on, and I'm going to show you what critical value means. So this slide I'm going to skip because it's exactly what I just showed you. But this slide is a little better because it sort of helps you visually understand what we're talking about. Looking at the formula here, so we have x bar plus or minus z. That means you first do x bar minus z times sigma over square root of n, and that will give you the lower confidence limit. And then you do x bar plus z times sigma over square root of n, and that will give you the upper confidence limit. So you have 2 values. So the lower limit will end up being here, and the upper limit will end up being here. And the area in the center is your 1 minus alpha, or that's your confidence level. So your critical value is based on this lower limit and upper limit. Okay, so now we're going to do a full word problem where you can see how to get your critical values and construct your confidence interval. Any questions for me before we move on? Okay, so moving on to the next slide. This is the example. We take a random sample of 100 Starbucks restaurants to determine the average amount of time spent by a customer on a Friday evening in December. X equals amount of time. X is distributed normally, the population mean, and a population standard deviation of 5. We find that the sample mean is 102 minutes. Find the 90% confidence interval for average amount of time spent. Okay, so let's say you get a question like this in your homework and you don't know where to begin. Well, the first thing is you're going to look for key terms and hints. So right away, this is one term, confidence interval. So you know that it's talking about confidence intervals. It has to do with chapter 11. At this point, you know that there are two types of confidence intervals. Either you're dealing with mean or you're dealing with proportion. Now, of course, you know it's mean because that's all I've been talking about. But let's say you were given this question and forget that it says mean right here. How would you know that this is talking about mean? Well, let's go back and read the question. We take a random sample of 100 Starbucks restaurants. So random sample, and the sample size is 100. Why did they do that? Because they want to find out the average amount of time spent by a customer on a Friday evening in December. So that means they want to know what the average amount of time is for that particular time, Friday evening in December, for all Starbucks restaurants, not just the 100, for all of them. So it's not specific if all of them, meaning all in the United States, all in New York State, all in New York City. I don't know. But they want to know what the average is for all of them. So they randomly select 100 and they find out that the average for the 100 in the sample is 102 minutes. So we're already talking about average. So I know this is going to be confidence interval for mean. So now make an estimate for all the restaurants, not just for the 100 restaurants. We know the 100 restaurants is 102 minutes. So now come up with a value that you can estimate the population mean. And you have to be 90% confident of the answer. Okay, so you're told what the confidence level is, 90% confident, and you're told that you're interested in the average amount of time. Now, usually this is not given to you, but what if I asked you, what does the continuous random variable denote? What is the continuous random variable in this case? Well, the continuous random variable is x. So I'm asking, what does x stand for? Well, x stands for a value that is continuous because we're dealing with normal distribution. So that means the data has to be continuous. And just to remind, continuous means something with a decimal or a fraction. So now how do I know what is x? Well, this is telling me, so these are my clues. This is telling me that this is x bar. So x bar is 102 minutes. So minutes is a time. So x equals amount of time. X is amount of time. And x is distributed normally with population mean unknown. So that's we need to find. We're given population standard deviation. Okay, so does everyone understand the question? Okay, so I'm going to start with a blank whiteboard, and we're going to solve this problem from the top. So the first thing I'm going to do is write the formula, because I know that eventually I'm going to use this formula. So that formula is x bar plus or minus z. This is my critical value, z subscript alpha divided by 2. So this is a subscript. It's not times. This is times sigma over square root of n. So that's the formula. Now I'm going to write down all the things that were given in the question. So the first thing is, how many Starbucks did they take in the sample? Do you remember? 100. Yep. Thank you. And then we were told that out of the 100, the sample mean, the average for the 100 was 102. Thank you. And I'm going to write minutes so we know the difference what's in here. Okay, what else? We're given sigma, population standard deviation, and that is, Jan, you said 5. Okay. So we have x bar, we have sigma, we have n. Now we need to find the critical value. Okay, so let me write that here. Z at alpha over 2, and it's plus or minus. So make sure you write that in here. Plus or minus z, that's what we don't know. So write that here as critical value. But we are told in the question that we have been 90% confident of our answer. So we're going to use that information to find the value. So if you recall, the critical value, z, can be found by first drawing the graph. So here's our normal distribution with our center. And now I'm going to mark my 2 points. This is going to be my lower limit and upper limit. But now this x-axis is not x, it's the z-axis, the standardized normal distribution, because I need to find my z values. So the point on the left is actually negative z at alpha over 2, and the right side is positive z at alpha over 2. Okay, a few more things for me to mark on this graph. The center is always going to be the shaded area. So when you construct your confidence intervals and you draw your graph, always shade the center. The shaded region in the center is my level of confidence. So that means this was given as 9% confidence. Yeah, this doesn't look like a 9, so I'm going to make it like a 9. 90% confidence. I'm going to remove the percentages and put it as 0.90. Okay, now for the unshaded regions. So the unshaded region together will be alpha. Individually, what is this alpha over 2 value? So this side is alpha over 2 and the other side is alpha over 2. Does anyone know what that value would be? Xiaoting, how did you get 0.05? So you're right. Can you explain how you got 0.05? So Armila, you say take. Okay, so I'm going to remove the percentages and say the same thing. Area under the curve is 1. So we do 1 minus the shaded region, which is 0.90. So that's correct, Xiaoting. That's what you got. So the entire area under the curve is 1 minus the shaded region of 90 and then divide it 2. Yes. So you're correct. All of you are right. So that's how you get 0.05 or 5%. So the unshaded area on the right is 5%, and this is also alpha divided by 2. So this is also 0.05. Any questions for me? Make sure you really understand how we're getting these values now, because I won't be able to come back to it later on. Okay, so now we understand the area. We still haven't got critical values, the plus or minus z values. So now I would have to look up my normal distribution tables or use Excel to get my critical values, my z values. Now there's two different ways you can do that. You could either get the negative z value, or you could get the positive z value. It's the same thing. One will have a negative sign, while one will have a positive sign. It's the same value. So you can do whatever is easier for you. I'm going to go with the negative z value. So if I want to find the negative z value, I need to know the area from negative infinity up to that negative z value. So in other words, I'm looking for 0.05 in the middle of my normal distribution tables, right? Because I'm looking for the area from negative infinity up to my negative z value. I found out that that area is 0.05. So I'm going to show you the tables right after I finish this entire calculation, because if I leave this, we won't be able to come back to this whiteboard. So on the normal distribution tables, the first page has all the negative values of z. So I'm looking in the center, 0.05, the closest thing to 0.05. And I find it a particular z value. And that z value is at negative 1.64. If you decided to pick negative 1.65, you would still get the correct answer, because by the time we plug all this into our main formula, the second decimal place doesn't really matter. Okay, so again, normal distribution tables, first page, because it's negative z, I'm looking in the center for 0.05. And I find it at negative 1.64. If you wanted to find the positive z, it would be the second page of your normal distribution tables. And you're looking for this entire area from negative infinity up to the positive z value, which means you take 0.05 on the left plus the 0.90. Yes, that's right. So, and then you're looking for 0.95. And then what's the value you should find for the z value? Yep, 1.4. So it's the same thing, either positive or negative. So now we have everything that we need. I'm going to go back to our formula and put our values in. So now x bar is 102. I'm going to write down minutes so we don't lose track of what it is we're trying to find here. Plus or minus critical value of 1.64 times sigma is 5 divided by the square root of 100. Okay, so now a couple of things before we calculate this. I would like to get first this. So I would like to get, type this in, standard error of mean. So can I have Brandon, can you give me the answer for standard error of mean, which is sigma over square root of n? And then Bipin, can you give me the next thing, which is margin of error? So Brandon, do you have that answer for us? Okay, anyone else has standard error of mean? 0.5, Diana, thank you. And then Bipin, did you have the margin of error? Okay, so Diana and Arzu, you have 0.82. Okay, so now we're going to answer the question. And I'm going to show it to you in two different ways. So the first answer is 102 minutes plus or minus 0.82. Okay, so this is the first way of answering your question. Question asked, determine the average amount of time spent. Oh, let me read it again. Find 90% confidence interval for average amount of time spent. So you have found that all Starbucks restaurants, a customer would spend 102 minutes plus or minus 0.82. So that's all based on that single value, but you've included the margin of error. So in your homework, you might have to give your answer using margin of error, this method, the point estimate plus or minus 0.82. So that's one way of giving the answer. The other way of giving the answer is having your lower limit and your upper limit as your confidence interval. So you have estimated the population mean, mu, and you're saying that mu is now going to be greater than, so can I have Erica, can you do the lower limit? So I'm asking you to do 102 minus 1.64 times 5 divided by square root of 100. So Erica, do you have that answer? Dongyan, you have it, right? So you took 102 minus 1.64 times 5 over square root of 100, and you got 101.18 minutes. And then Dongyan and Diana, you did 102 plus 1.64 times 5 over square root of 100, and you got 102.2 minutes. So this is the second way of, that's supposed to say minutes, second way of getting your answer with a lower limit and an upper limit. So you can see here that it's not difficult to come up with your confidence intervals. And it was all based on collecting data for a sample and getting your sample result, your sample stick. So you have these two different ways of presenting your answer. So now this says a population mean will be greater than or equal to. Remember, it doesn't matter with continuous data, with the normal distribution, if I included the equal sign or not. But you know that the true population mean is going to fall somewhere in between this. And you're 90% confident of your answer. So the calculation is not difficult. The last thing is the most important thing. And that's what I'm going to type in here now. So the last thing is the interpretation. The interpretation is how you interpret your answer. So I'm going to type it first. We are 90% confident that the average amount of time spent by a customer on a Friday evening in December at all let's see, Starbucks falls between 101.18 minutes and 102.82 minutes. Okay, Christopher, you have a question?
Yeah, I'm just trying to understand conceptually what we're doing. Are we trying to find a statistical average given the probability of an action of a certain population?
No.
Okay.
So we're trying to estimate, we're trying to predict what the average is for the entire population. So nothing to do with probability. We're trying to estimate what the average is for the entire population. And we are basing it all on the sample result. And in order to make
Okay.
an estimate about the entire population, we're going to use this method of an interval. So we come up with a range
Okay.
of numbers, and we're saying that the true population mean is going to fall somewhere in between here. Okay, so this is the method that we use, the confidence interval method. And it's so useful, and it's actually quite great because you can state how confident you are of your answer. So this is how you would correctly interpret your answer. We are 90% confident that the average amount of time spent by a customer on a Friday evening in December at all Starbucks falls between 101.18 minutes and 102.82 minutes. So even if you do your entire calculation correctly, and you know your homework has many different choices, right? A, B, C, not choices, but many different parts. So the first part might ask you for the standard error of mean. The second part ask you to calculate the margin of error. So once you do all that accurately, the final thing is the interpretation. Once you get the interpretation wrong, it's not useful just to know the calculation, because the interpretation is really the most important. You should be able to interpret what it is you calculated. So you're 90% confident. This is the average, not for just the 100 Starbucks that you have in your sample. This is the average for all the restaurants. And you're saying that the true population mean is going to fall between this lower limit and upper limit. So now I'm going to move on to the normal distribution table to show you where I got the 1.64 from for the critical values. Any questions for me before I switch over to the normal distribution table? Because once I leave this whiteboard, we're not going to see this information again, so I suggest you take a picture or something of this before I switch over. Any questions for me? Okay, so actually before I switch over, I just wanted to mention you might be reading in the news or you might see an article where they're talking about an average and they say that this is what the average number of people think of a certain referendum, plus or minus something. So this is where the plus or minus part comes in, the margin of error. This is how they get margin of error. You might be used to seeing it as a percentage, the percentage of people who feel a certain way, plus or minus a margin of error. So the percentage comes in when we do confidence interval for proportion, which will be the next couple of classes. But it's the same concept, percentage plus or minus margin of error. So that's where that's coming from. Okay, so now I'm going to share the normal distribution tables. Any questions for me before I move on? Okay, so these are the tables. Let me make it a little bigger. Okay. So just to draw it on the top here, we said that this is our normal distribution curve, and my lower limit was here, my limit was here, so that means my negative critical value is on the left, so that would be minus z at alpha over 2, and on the right it would be positive z at alpha over 2. And then the center was shaded. So we always shade the center when we talk about confidence intervals. We were told that level of confidence is 0.90. And we found out that the two unshaded regions was alpha divided by 2, which we calculated to be 0.05. Right? So let me try to fit that in there, 0.05. And same thing on this side, that would also be 0.05. So for me to find critical value negative z, I have to know the area from negative infinity up to this z point. So that area I know is 0.05. So I have to look in the middle of the table for area of 0.05 and then find the corresponding z value. So if I look in the center table for 0.05, I find it at 2 spots here. It could be either one of those values is 0.05 really. And if I look at the corresponding z value, it's negative 1.6. If I go with this one, then negative 1.64. So that's why I said if you chose negative 1.64 or negative 1.65, it's really the same thing. So that means this negative critical value is negative 1.4. And if I looked up my positive z value, then I would look up from negative infinity up to here. So I'm looking in the middle of the table for 0.95 in the middle of the table. So that's the second page. And if I go to the second page, I'm going to lose my graph. So I'm not going to the second page. If I looked in the center of the table for 0.95, I would find my positive z-value of 1.4. Any questions for me? Okay, so that's, if you're comfortable with z-table, you can use this map. If you are comfortable using Excel, that's fine too. Okay, but you need to know where the z-values are coming from. So that's why it's good to understand the tables. Okay. Yep, Rad, I agree. If you're comfortable with Excel, you can do that. I also want to show you that since we use technology, I don't expect you to struggle trying to find this. So you can, going back to our slides here, you can refer to this slide, which is really showing you that if your confidence level is 90, then you could take the average of those values, 1.64 and 1.65, and use 1.645. I think your homework kind of shows you to do that. If your confidence level is 95, then use a critical value of 1.96 and so on. Okay, so you are allowed to refer to this table, but you need to understand where the Z number is coming from. Going back to our previous question, so this is we came up with, and the next slide shows you the solution, what I did to come up with that number, 102 plus or minus 0.82, and that's your interpretation. Any questions for me? Okay, so let's do this poll then. It's in two parts. Let's do the first one first. 90% of all Starbucks restaurants have customers spending an average amount of time between 101.18 minutes and 102.82 minutes on a Friday evening in December. So let me put the poll up and then you can give me your answer. Okay, so A is true, B is false. Okay, another 30 seconds. Okay, I'm stopping the poll here. So you can see here, most of you chose answer choice true, and actually 10 of you are correct. So the answer that is false. So who wants to explain to me why this answer is false?
The 90% doesn't explain the number of restaurants. It explains people within the restaurant.
Say it again, Judah.
The 90% doesn't explain the number of restaurants. It explains the number of people in the restaurant.
No, I don't exactly agree with you. Red?
So the 90% basically explains that you're 90% confident that it'll be between those minutes, but that answer applies to all Starbucks restaurants.
Okay,
Makes sense?
that's okay. I can go with that. So the problem with this statement number one, is that it's saying 90% of all Starbucks, which is incorrect. Although the numbers that we calculated are all correct, the problem is this. It's not 90% of the restaurants. What we found out, it applies to all of them, all the restaurants, not 90% of the restaurants. And we are 90% confident of our answer. So Shamaya, you're right. It's 90% of your own personal confidence level. So Priscilla, you're right. It's not the 90% of the population. So Judah, you were halfway right. You were saying it's not the 90% of the population. So that's what's the problem with this sentence. It's not that. Okay, so that was the problem. Let's look at the next one. Statement number two, the average amount of time is between 101.18 minutes and 102.82 minutes 90% of the time. So polling is started. That's true, Jude. This is probably completely off for this year, this December. Okay, another 30 seconds. Okay, stopping here. So again, you can see that most of you chose true and 18 of you got it right. So the answer is false. Okay, so who wants to explain why this one is false? Any idea why this second statement is false?
Wouldn't it be for the same reason that 90% is the confident level and not the percentage of time?
Okay. Tusha, do you want to add to that?
I was going to say the same.
The same. Okay. So you're both right, Elizabeth, Tusha, Priscilla. That's the issue, right? That 90% of the time. This statement is implying that the true mean kind of varies. It doesn't happen all the time. That's not correct. The true mean happens all the time. And we are 90% confident of our answer. Okay, so according to the calculation, according to past historical data, according to population standard deviation that we used for this example or this experiment, based on all that, we are 90% confident of our answer, and we know that it's going to happen all the time, all the Starbucks. So again, the interpretation is really the most important thing for confidence intervals. Okay, so the last thing for today is this slide, and it's about sampling error. So sampling error is also called margin of error. So what is margin of error? It's the difference between the estimator and the parameter. So what you're using to estimate and what you're estimating, which is your population parameter. In our case, it was the population mean. So it is the estimate used in constructing your confidence interval. So if I had to quickly draw my graph here, and my confidence interval would be from here to here. This is my lower limit, and this is my upper limit. So I'm just marking half of it here, this half here. For mean, it's x bar plus or minus z sigma over square root of n. It's the right side of that formula. So it means it can be positive or it can be negative. Positive or negative. Half the width of the confidence interval. So here is half the width of my confidence interval. This is half my width. So that's what we're saying. It could be positive or it could be negative. This would be positive, this would be the negative portion of my formula here. That right side of the formula, so it's half the width of the confidence interval. That is sampling error. That is my margin of error. It's the maximum error we're willing to tolerate. So from the confidence interval formula, that's your ME, your margin of error, and we got the answer of 0.82. Okay, so any questions for me? So you need to be aware of how to calculate this because, again, your homework will ask you specific questions about margin of error or sampling error. Okay, so I'm going to stop here today.